Previous lesson 4.10 was about this concept of integration by substitution, and when you went through that video, you likely noticed that it seemed like every time you did a U substitution, it just sort of worked perfectly. And in the lesson that I'm working on today, I'm going to be covering, so what happens when that doesn't work? There are some times where multiple substitutions actually sort of make sense. And so I'm just going to jump straight into an example here. Suppose we want to take the antiderivative of x times the square root of 2x plus 1 dx. Now, as you continue to try and get better and better at U substitution, the continual challenge is always going to be, what am I supposed to choose as my U? How am I supposed to know what U is supposed to be? And in the last lesson, I sort of gave the hint that it's great to choose something whose derivative shows up elsewhere in the problem. And so that's certainly the first hint that I can give. That was the tip I gave previously, that you should use an expression whose derivative shows up elsewhere in the problem. The second tip that I would give is that often it's good to choose something that is being plugged into some other function. I don't know if I said this in yesterday's lesson, but integration by substitution is kind of like undoing the chain rule. So, for instance, in this problem, notice there's this 2x plus 1 that's inside the square root. That thing would have required the chain rule if we were doing the derivative. Something like that is often a good candidate to be your U in a substitution if it's being plugged into some other function, like this 2x plus 1 is being plugged into the square root. So in this particular instance, I'm going to sort of go with the hint that I was leading to before. I'm going to choose my U to be 2x plus 1. And just like you learned from yesterday, as soon as you choose your U, immediately we write down the differential. Du is 2 dx. And then immediately after that, we solve for dx, and we get that du over 2 is dx. And at this point, we're sort of ready to go back to the problem and attempt to plug things in. So this is now the integral. I'm going to leave the x alone, sort of in hopes that it'll cancel. We'll see what happens. Times the square root of, well, remember that our 2x plus 1 is effectively our u substitution. So this is the square root of u. My dx, I know I can change that out to be du over 2. So this is times du over 2. And unfortunately, there isn't an x on the bottom. You know, in all of yesterday's problems, you guys would have seen like, hey, the x cancels out. Yay, we win. At this stage in the problem, we're kind of stuck because there's an x left. There's only supposed to be u's left, and we don't know what the deal is with that. And so the secret is this. Note the title of the lesson today is about multiple substitutions. What it hints at is that this substitution, this 2x plus u equals 2x plus 1 substitution, can be used more than once. And it can be used in multiple forms. If u is equal to 2x plus 1, isn't it true that u minus 1 is equal to 2x? For that matter, isn't it true then that 1/2 of u minus 1 is equal to x? Like, if your original substitution is correct, anything that leads mathematically from that is also going to be true. And this statement here, just me solving up here for x, means that x can be replaced with this expression. So I'm now going to take that and bring it back to the problem. I now have the integral of 1/2 u minus 1 times the square root of u times du over 2. And just like that, our integral has transformed from being entirely in terms of x to now being entirely in terms of u. Now we just have to hope that we can do the integral of that thing. So the 1/2 here and the 2 on the bottom here, those are both constants, so I can pull those out. I can certainly look at something like 1/4 the integral of u minus 1 times the square root of u du. And this integral should be like ringing bells from what we've been doing for the few days before yesterday, where you were dealing with how to do any given antiderivative. I'm just going to distribute this square root of u into this expression. If you think about this as being u to the 1/2 power, we can move it in pretty easily. We'll end up with 1/4 the integral of u to the 3/2 power minus u to the 1/2 du. And from there, I mean, like, that's easy. These are just applications of the power rule. I'll leave my 1/4 on the outside. Doing the antiderivative of u to the 3/2 means I'm going to increase the power by 1. So it's going to become u to the 5 halves times the reciprocal 2/5 minus u to the 3 halves times the reciprocal 2/3, and we'll have our plus c. Right? Then I'll distribute the 1/4 in, and I'll get, let's see, it would be 2/20, so I'm going to reduce that to 1/10 u to the 5 halves minus, and the same thing here, it would be 2/12, but I'm going to write that as 1/6 u to the 3 halves plus c. And we're almost done. The one thing I'll say is that our original problem, you remember, was all in terms of x. And I'd really like my answer to be in terms of x. So this u substitution that we use, this 2x plus 1, I'm going to bring that back now that I'm at the end of the problem. Right? So, recall we knew that u was 2x plus 1, so now I'm just going to plug it back in. I now have 1/10 2x plus 1 to the 5 halves power minus 1/6 2x plus 1 to the 3 halves plus c. And in some sense, this answer is done. I mean, like, we rejoice that we even got that far. If you're interested in seeing how this can be simplified, I will sort of take one step further. In some sense, both of these things have a square root in them, and that could be factored out. This is one of those things where it might show up in a multiple choice. I don't know that I would do it. I don't know that the AP exam is going to do it, but it's worth mentioning. If I were to factor out sort of like a 1/2 power from this one and a 1/2 power from this one, we could get ourselves into a position where we have the square root of 2x plus 1 times, and what would be left is still the 1/10, but now this will be 2x plus 1. If you think about it, it was the 5 halves power. I took a 1/2 power away from it, so now it'll be the 4 halves power, in other words, squared. And then minus 1/10, and the same thing. This was 2x plus 1 to the 3 halves. If I take away one of those, I'll only have 1 power left. And that's, oh, sorry, just realized that I wrote a 1/10 there. This should be a 1/6. And in some sense, that's a slightly prettier looking answer. You could make the argument that you could also factor out a 2x plus 1. There's all kinds of other stuff we could do, but I'm now over 7.5 minutes, so I'll stop now. This is the concept of multiple substitutions. The challenge you guys are going to find as you go forward is just knowing what method to use in a problem. And a lot of it, like I can't emphasize enough, you just have to be willing to try things. You have to be willing to do U substitution, follow it through, and see what's going to happen. So that's all I have for this video. I will see you in the next one.